Hi everyone, myself A.K. Mugdum, working as lecturer in SIT Polytechnic Edra, Ichulkarnji. Today in this session, we discuss about the introductory part which is given under the chapter number 1, non-conventional machining methods. In previous lecture, we discuss about the syllabus contents which are mentioned under this subject, non-conventional machining methods. So, uh, there is the part which is covered under this lecture regarding non-conventional machining methods, introduction parts we can discuss in further slides. First of all, there is the unit number 1, non-conventional machining methods. Here there is the teaching hours are allotted for this particular first chapter, that is the 10 hours, and total marks for this unit number 1 there is the 12 marks. So what are the topic contents are given over here? The chapter first 1.1 fundamentals of non-conventional methods. Under that there is the needs and types of non-conventional methods, importance of methods. Under 1.2 working principle, setup, process parameters of such as EDM, wire EDM, ECM, plasma arc machining, abrasive jet machining, USM means ultrasonic machining, EBM, electron beam machining, and LBM. Next 1.3 advantages, limitations and applications of these above various machining processes. First of all, introduction to machining process. Here, machining is a broad term to describe removal of material from a workpiece. The basic concept of machining is what? Anyhow we want to remove the material from the workpiece surface and change its shape and required shape of the component we are produced at the end of machining process. So there are the machining categories are there. First category is cutting. Under the cutting involves single point or multi-point cutting tools. Single point means all of you handle the lathe machine, or that lathe machine there is the single point cutting tool is actually used. The multi-point best example is the milling machine, or that milling machine also we are using the multi-point cutting tools. So these two cutting tools we are actually remove the material or cut the material from the workpiece surface and give the shape and size of that component. So there is it should be helpful for easily clearly define the geometry of the components. So that is the first category, cutting. Second one is the abrasive. Small particles are removed from the workpiece such as grinding. All of you know the grinding operation. In that grinding operation, there is a grinding wheel which is rub over the workpiece material or workpiece component, and then afterwards small particles of the material which should be removed from the workpiece surface, and then afterward finished component is ready for a further application. So that is the second category, abrasive. Third one is the non-traditional machining. That is the important point which is useful for our today's lecture. That is in that non-traditional machining, utilizing electrical, chemical or optical sources of energy. It is a non-traditional because that is a not using a traditionally, because there is the specific operations, specific machining components for that purpose non-traditional machining is actually used. So we are discuss in the further session, there is the one by one, but here there is the machining is broadly classified into the main two groups. First one is the traditional is there, second one is the non-traditional is there. Under there is of traditional, there is the chip removal process is there and abrasion process is there. Under the chip removal such as turning, milling, drilling, planing, shaping, broaching, gear cutting, boring, means these all of the operations which are comes under the chip removal process. Means we are remove the material from the workpiece surface and give the shape and size of that component. So that's why these all operations are comes under the chip removal process. Next one is the abrasion, means small particles of the components which are removed from the workpiece surface. So that's why this method is called as the abrasion method, which comes under the traditional process, such as polishing is there, buffing is there, lapping is there, grinding is there, honing is there, super finishing is there. So these are the abrasions methods for a finishing purpose or improve the surface quality of the component. We are actually use this abrasion machining process under the traditional machining process. Next, another important part which is according to our syllabus, that is a non-traditional process. Under that there is a abrasion is there, and next one is the erosion is there. Under the abrasion, there are some abrasive particles are used for remove the material from the workpiece. So that's why it is called as abrasion. And here erosion means eroded the material, like while there is a corrosion which is covered by the metallic surface, and there is the small layer by layer with material which should be removed from that workpiece component. Same way material which is removed under the erosion process also. So under the abrasion, there is the abrasive jet machining is there, ultrasonic machining is there, water jet machining is there, magnetic abrasive is there, finishing is there. And next, another part, there is the erosion. Under that erosion, electrochemical machining is there, electro discharge machining is there, laser beam machining is there, plasma beam machining is there. So this one is the broad classification of machining process. Next, there is the traditional machining versus non-traditional machining. That is the very important comparative between these two. We clearly point wise discuss in the next slide also. But here there is a primary source of energy. In a traditional, there is the mechanical energy is required for machining, and in non-traditional there is the electrical energy is also used, chemical energy is also used, optical energy is also used. Means there are the n number of various energy primary source which is used for the non-traditional. Next one is the primary method of material removal. In traditional there is the shearing. In non-traditional does not use shearing. That is a very important advantage of this non-traditional machining. Example, abrasive water jet cutting is there, etc. Or so many methods are actually used for a non-traditional process. Next, here in this slide we generally talk about the different material removal process, which are divided into mainly two groups. First one is the conventional machining process. Actually, traditional or conventional, both the names are same. Another word for the traditional machining is the conventional machining. In this process, mostly remove material in the form of chips. That is a very important. How the chips are removed? By applying forces on the work material with a wedge-shaped cutting tool that is harder than the workpiece material. So basic condition for a conventional machining process is what? There is the tool is harder than the workpiece material. Then and then only easily you can remove the material from that workpiece surface. Otherwise, if you take an example, if the tool material is aluminum and you want to machine the workpiece material like a MS, in that case there is the no material which is removed from the workpiece surface in a conventional machining process. So basic condition for a conventional machining process is what? There is the tool is harder than the workpiece. So then and then only there is a material or there is the chips which are removed from the workpiece surface, and then afterwards we are prepare the shape and size of the component. So such examples of the conventional machining processes are turning is there, boring is there, milling is there, shaping is there, broaching is there, slotting, grinding, etc. So many machining methods of a conventional machining process. There are the some of the conventional machining processes are listed over here. Next one is the non-traditional manufacturing process. Here it is define a group of processes that remove excess material by various techniques involving mechanical, thermal, electrical or chemical energy or combinations of these energies, but do not use a sharp cutting tools as it needs to be used for traditional manufacturing process. The basic difference between traditional and non-traditional or conventional or non-conventional is what? In a conventional machining methods, there is the tool is harder than the workpiece, which is a basic condition required for a machining practice. But while you think about the non-traditional machining, in that case, there is the need not to use the tool is harder than the workpiece. There is the so many techniques are used for a machining like a mechanical, thermal, electrical, chemical or combination of any two. But here there is what is the condition required for a conventional machining? That conditions are not defined under the non-traditional machining. This is very useful for various machining of components. Like examples of non-traditional machinings are abrasive jet machining is there, EDM is there, ECM is there, LBM is there, EBM is there, etc. So many non-traditional manufacturing processes are also used for various industry, for various applications. So we can discuss according to our syllabus one by one. So this is the different material removal processes. Next, we turn to the non-traditional processes. What is the definition of non-traditional processes? A group of processes that remove excess material by various techniques involving mechanical, thermal, electrical or chemical energy or combination of these energies. But important thing is what? There is the do not use a sharp cutting tool in the conventional sense. So that is the basic difference between a traditional and non-traditional process. Next, non-traditional machining. Traditional machining is mostly based on removal of materials using tools that are harder than the materials themselves. So already we have discussed this part. Next one is the new and novel materials. Because of their greatly improved chemical, mechanical and thermal properties are sometimes impossible to machine using a traditional machining processes. So that is the actually limitations of traditional machining. Whatever the limitations under the traditional machining is there, that limitations are overcome under the non-traditional machining. So that's why here non-traditional machining nowadays very useful for novel materials or newly we are composite materials or some we are prepare for that materials. Non-traditional machining is very useful. Next, traditional machining methods are often ineffective in machining hard materials like ceramics and composites or machining under very tight tolerances as in micro machined components. So this is the drawback of traditional machining. That is also we are overcome under the non-traditional machining, because in traditional machining there is the limitation is what? Whenever the tool is harder than the workpiece, then and then only material which should be removed from the workpiece surface. Otherwise, already I am given the example of if the tool is aluminum and the workpiece is a MS material. In that case, material which is not removed under the traditional machining processes. So, how you can remove the material in that particular condition? There is the only way of machining is the non-traditional machining. So these are the various limitations of traditional machining. How we can overcome with the help of non-traditional machining only. So next one is the need to avoid surface damage that often accompanies the stresses created by conventional machining. Example, aerospace and electronics industries. There is the surface damage. While you take the best example of lathe machine, while you carry out the operation over the lathe, in that case tool which is come into contact with the workpiece surface, in that case there is some wrinkles or some scratches which are created over that surface. So it should be reduce the strength, it should be reduce the surface roughness value of that component. In that case there is the certain drawbacks of traditional machining is there, that should be totally avoided with the help of non-traditional machining. So that's why there is some few advanced industries, non-traditional machining having so many applications, like aerospace industry is there, electronics industries are there. In that industry, this non-traditional machining which play very important role. It is a very important question. Why you heard the name non-traditional? Why actually non-traditional which is come into the industry application? It is the important question at the initial stage while you learn the non-traditional machining methods, because situations where traditional machining processes are unsatisfactory or uneconomical, it is the important thing. Whenever the traditional machining which is unsatisfactory, in that case there is the in front of every industrialist, every who is carry out the different operations over the machining, different operations of the component. In that case, there is the in front of that industry or that manufacturer having a only one solution of non-traditional. The first one is the workpiece material is too hard, strong or tough. Next one is the workpiece is too flexible to resist cutting forces or too difficult to clamp. That is a very important advantage of the non-traditional machining. Here, whenever workpiece is too flexible or to resist the cutting forces, in that case, it is difficult to clamp over the different clamping devices in a traditional machining processes. So in that case, there is the non-traditional is a very important machining practice which is actually used for the industry. Next one is the part shape is very complex. Whenever the complex shape geometry is there, in that case, there is the some internal or external profiles or small holes are there. In that case, there is the limitations of traditional machining processes. To overcome that all limitations, there is the only one solution is a non-traditional machining is there. Because traditional machining having a only plain turning operation is there, plain milling is there, or maybe the some side milling, face milling, that type of operation which are covered under the traditional machining. But whenever you want to create this different complex geometry shapes or different external or internal profile cuts or you want to remove from that surface, in that case there is the non-traditional machining is a very important. Next one is the requirements for surface finish and tolerances are very high. Nowadays, whenever you machine any component, in that case, requirements of surface finish and tolerances are very important according to the part of manufacturing. So in how you can fulfill that requirement of the customers or requirement of that industry. Because while you go through the traditional machining, once you complete your traditional machining, there are the further super finishing operations you want to carry out over that component. Then and then only you can maintain the surface finish or tolerances of that component. But with the help of that non-traditional machining, once you carry out the non-traditional machining over that component, there is a surface finish as well as tolerances which are easily maintained at a one stroke only. So that is the very important advantage of a non-traditional machining. Next one is the temperature rise or residual stresses are undesirable or unacceptable. So this one is the important disadvantage of or limitation of there is the traditional machining. There is the some residual stresses which are generated at the time of machining, undesirable, unacceptable, rise of temperature. There are so many drawbacks of traditional machining that should be easily overcome with the help of non-traditional machining, like EDM is there, wire EDM is there, ECM is there, water jet machining is there, abrasive jet machining is there, plasma arc machining is there, laser beam machining. So many machinings, non-traditional machinings are actually used to overcome these all difficulties. So at the end of this slide, there is the simple meaning of why non-traditional. There is the simple answer is what? Whatever the limitations of traditional machining is there, that should be easily overcome with the help of non-traditional machining. For that purpose, we are actually use the non-traditional machining for the various application in the industry. Next, there is a comparison of traditional and non-traditional machining techniques. The first one is the microscopic size chip formation. That is the traditional machining, and in non-traditional microscopic size chip formation, both having the same. There is the no actually difference between the chip formation. Second thing is very important. There may be a physical tool present. Example, cutting tool, single point cutting tool is there, multi-point cutting tool, any cutting tool is there. There is the physical contact with the workpiece surface. Then and then only the material which should be removed from the workpiece surface under the traditional machining. But in non-traditional machining, here there may not be a physical tool present except in ECM. In electrochemical machining, there is the only tool is available. Rather than that, there is the no tool is present, or there is the no physical contact with the workpiece surface. So that's why this is the very important advantage of this non-traditional machining. Next one is the cutting tool is harder than the workpiece at room temperature and machining condition. So this is the requirement of traditional machining. Then and then only you can carry out the machining practices with the help of traditional machining. But while you go through the non-traditional machining, there may not be a physical tool present except in ECM. Means there is the no surface contact with the workpiece. So there is the need not to worry about the tool is harder than the workpiece. There is the basic requirement which is under the traditional. So in non-traditional there is a tool, either it is a soft, hard, there is the no issue. Only there is the issue is what? There is the no physical contact between the workpiece and the tool. Next one is the material removal takes place due to cutting action. It falls in mechanical energy domain. So this is the basic thing of traditional machining. Next, in this particular non-traditional machining, they fall in different energy domain, like a mechanical is there, thermal and chemical. There are the so many domains are there. But in traditional machining, there is the only mechanical energy domain. Under that, material which should be removed, because there is the physical contact between the workpiece and tool is there. So due to which there is the mechanical action which is carried out in that particular process. So due to which there is the material which should be removed from that workpiece itself. So that's why this is the only mechanical energy domain is there. But while you go through the non-traditional machining, in that case there is the mechanical is there, thermal is there, and chemical is there. There are the different energy domains are there. Next one is the direct contact of tool and work. There is the already we have discussed that part. There is the physical contact between the workpiece and tool is that is the basic requirement of traditional machining. Here there is the no direct contact of tool and work. There is the very important advantage of non-traditional machining. Next one is the lower accuracy and surface finish. That is the drawback of traditional machining. But here in this case, higher accuracy and good surface finish, that is the important advantage of non-traditional machining. Next one is the tool life is less due to high surface contact and wear. Due to there is the physical contact between the tool and workpiece, there is the friction which will be generated, due to which there is the heat will be produced in between the workpiece and tool, due to which there is the life of tool is a minimum compared to non-traditional machining. Here in the non-traditional machining, tool life is more because there is the no need to physical contact between the workpiece and tool. So due to which there is the tool life is a comparatively high with the traditional machining. Next one is the higher waste of material due to higher wear. So due to which there is the unnecessarily there is the friction between the tool and workpiece which is carried out under the traditional machining. So due to which there is the unnecessarily increase the temperature, due to which there is the high wear which will be produced of that either workpiece or either tool, which is happen at the time of machining. Next one is the non-traditional machining, in that there is the lower waste of material due to low wear. So due to which there is the waste of material is reduced because of non-traditional machining. Next one is the advantage of traditional machining is what? Lower capital cost. But drawback of non-traditional machining is what? There is the higher capital cost. That is the important comparison between these two, traditional and non-traditional. Next one is the last one, easy setup of equipment and complex setup of equipment. That is the important advantage of traditional, and this one is the drawback of this non-traditional machining. So this much is the difference between the traditional and non-traditional. Next one is the need for non-traditional machining. What is the needs of the non-traditional? That is a very important. If you don't know what are the needs of traditional non-traditional machining, then there is the no use of to learn this particular chapter. Extremely hard and brittle materials are difficult to machine by traditional machining processes. So this is the drawback of traditional machining. Means whenever there is the hard workpiece material is there, brittle materials are there. In that case, there is the difficult to machine over the traditional machining. So in that case, non-traditional machining is a very important. When the workpiece is too flexible or slender to support the cutting or grinding forces. In that case, there is some flexible workpiece material is there, or some slender means long jobs are also there. In that case, to support the cutting or grinding forces, in that case there is some unnecessary wear of the tool is there, imbalancing of the workpiece is there. In that case, we cannot maintain the surface accuracy, surface dimensional accuracy. So in that case, non-traditional machining is the best solution for that type of a machining. Next one, when the shape of the part is too complex. Already we have discussed that part. Whenever the complex shape geometry is there, means in that case there is so many profile terms are there, so many arcs are there, so many curves are there, or some internal shapes are you want to produce. In that case, there is the non-traditional machining is the best solution. Whenever you go through the traditional machining, in that case there is so many problems you are faced at the time of machining. So this is also one more important advantage of non-traditional machining, to easily we can machine the complex geometry. Next one is the machining of composites. That is the very important advantage of non-traditional or needs of non-traditional, because whenever the composite materials are there, so many nowadays composite materials are come into the market. So each and every composite material we want to machine with the help of different machining methods. So in that case, that composite material having a different hardness is there, different melting points are there, different there is the surface roughness we want to maintain. In that case, there is the non-traditional machining is a very important solution for the machining itself. Next, why non-traditional processes are important? We already discussed newly developed metals are there, some metals which are difficult to machine over the traditional. In that case, non-traditional is a very important machining method. Next one is the need of unusual and complex part. Already we have discussed this part. Next one is the classification of non-traditional processes by type of energy used. Basically, non-traditional machining methods or processes which are classified under the various energy groups. First one is the mechanical energy. Erosion of work material by a high velocity stream of abrasive or fluid or both is the typical form of mechanical action. All of you observe the service station, means all of you clean your bike or car over the service station. In that case, there is the high velocity water stream which is continuously thrown over your bike or car in that mud surface, and due to which there is the mud which is removed from that workpiece, your car or bike. So same mechanism which is used under the water jet machining, which is comes under the mechanical type of energy which is used for the machining method. In this case, there are some abrasive particles are definitely add into that water or maybe the any other liquid which is used for that machining. Next one is the electrical. In that electrical energy, there is the electrochemical energy to remove the material. Reverse of electroplating means in that electroplating, what we are doing, we are layer by layer we are improve the component or material thickness. But in this electroplating or electrochemical, what is actually happen? We are removing the layer by layer metal from that workpiece. So that's why that is the reverse of electroplating. Next one is the thermal. Here thermal energy usually applied to small portion of workpiece surface, causing that portion to be removed by fusion and or vaporization. Here there is the thermal energy is actually used. Means thermal means what? In between the workpiece and tool, where you increase the temperature, and due to the vaporization or maybe the fusion, we are removing the material from that workpiece surface. So this energy is nothing but a thermal energy. Next one is the chemical energy. Chemical agents selectively remove material from portions of work part while other portions are protected by a mask. Means some agents are actually used like a chemical, and that agents are actually remove the material from the workpiece surface, and which are diluted, actually remove small particles which are diluted into that chemical itself. So this is the last energy which is used for the non-traditional machining processes. So these are the four energy methods. Next one is the, here there is the broad classification is there. Here there is the mechanical. Under the mechanical there is the ultrasonic machining is there, water jet machining is there, abrasive water jet machining is there, ice jet machining is there. That all machining method which are comes under the mechanical processes or mechanical energy use. Next one is the thermal. Under the thermal there is the electrical discharge machining is there, or in short there is the EDM is there. Next one, electron beam machining, or in short EBM. Laser beam machining, LBM is there. Ion beam machining, IBM is there. Plasma beam machining, PBM is there. So these are the various thermal energy used for the machining of non-traditional processes. Next, last one is the chemical and electrochemical. There is the chemical machining, CHM is there. Photochemical, PCM is there. Electrochemical machining, ECM is there. So these are the various non-traditional processes which are classified under the mechanical, thermal, chemical and electrochemical. But only few machining methods which are defined for your syllabus. So we can discuss only related to that topic, that contents in a further lectures. So let us today we stop over here. Thank you very much.